In this video, I'm going through P2 and section 7.1, increasing and decreasing functions. So increasing functions, increasing graphs or parts of the graphs have positive gradients, and decreasing functions have negative gradients. Now, the textbook also introduces some inequalities, and they talk about strict inequalities. So I wanted to define what those meant. Strict inequalities are inequalities that don't have an equal sign, like this one. So something like this is not a strict inequality, but that is. Now, I've put what the textbook says. It basically said exactly what I've said here, using a little bit more. So a function f of x is increasing on the interval a, b, so between 2 points on the graph. So for example, here, that's a, and up to there, that's b. So that's the interval. And this function is decreasing in the interval a to b if the gradient is bigger than or equal to 0, if the gradient is positive for all values of x, such that x is bigger than a and smaller than b. So it's just defining in this interval all the values of the derivative of dy over dx are going to be positive, or in this case negative because it's decreasing, between that range. And what they've said is if you need to show that the function is increasing or decreasing in your exam, you can use either strict or non-strict inequalities. So you can write them with an equal sign, or you can write them without an equal sign. They're not going to take off any marks if you use either of those. And they've given two examples. This function you can see is increasing. It's sloping upwards throughout for all real values of x. This function is different. You have a decrease up to here. This is a turning point, so dy over dx is 0. Then it increases up to there, and that's a turning point. And then it decreases again, and that's a turning point. And then it increases. So you have to define your interval. The function f of x is increasing on the interval -1, 0. So it's increasing from -1 to x is 0. And decreasing on the interval from 0 to 1. So that's the decrease here. X is 0, x is 1. So a and b, our values are the interval for x. It's not a coordinate. It's not written like that as a bracket. It's an interval written with those brackets. Okay, so let's have a look how we do this. Show that the function f of x is x cubed plus 24x plus 3 is increasing for all real values of x. My step 1 is to differentiate. Okay. So this is 3x squared plus 24. Now, how does this tell me that all the values of x are going to be positive? Well, I have an x squared here. Remember, anything that is squared becomes a positive number. So I start with that. X squared is bigger than or equal to 0. It's always positive for all real values of x. Therefore, 3x squared multiplying by 3, a positive number, and then adding, this is an addition, 24, is also going to be bigger than or equal to 0. I would just put bigger than 0 for all real values of x. Therefore, the function is an increasing function for all values of x. Now I wanted to show you an example where you were showing that it was a decreasing function. So I got this from exercise 7a. So it says, show that the function 4 minus x brackets 2x squared plus 3 is decreasing for all values of x, real values, real numbers. Okay, so my step 1 is to differentiate. Well, actually, my step 1 is to multiply the bracket. That's the first step. So f of x is 4 minus 2x cubed, and then minus 3x. So when I differentiate, I get negative 6x squared minus 3. So I start with the x squared. X squared is always positive, is bigger than or equal to 0 for all values of x, or all real values of x. Therefore, when you multiply a positive number by a negative number, it's going to be always smaller than or equal to 0. It's always going to be negative for all real values of x. So that's going to be negative. Therefore, when you get a negative number and subtract it by 3, it's still going to be negative for all real values of x. You can combine those two. Therefore, the function is decreasing for all real values of x. And that is it. That is increasing and decreasing functions.